Hello friends, you are welcome to the GMAT 41's circuit theory class. We are going to look at the current and the voltage divider rules, CDR and VDR respectively. The point in this our class today is to determine the current that flows through a particular resistor in a given circuit, and the voltage across a particular resistor in a given circuit, especially in a situation where you are dealing with a series parallel network circuit. Before we move on into this, recall that from our previous class, we've already established the formula for determining the total resistance in a situation where all the resistors are arranged in series. We also established the formula for calculating the total resistance, otherwise known as the effective resistance or the combined resistance, in a situation where the resistors are arranged in what? In parallel. We also looked at how we can calculate the total resistance in a series parallel network, for which I stated that all we need to do is to resolve towards the source. That is towards where we have the cell. Are you following, right? What is producing the current? And for us to be able to determine resistors that are arranged in series and resistors that are arranged in parallel in a given series parallel network arrangement, we have to know how current moves in such circuits. Knowing how current moves, knowing the point where current divides, I refer to that point as a principal node or a principal junction in that last class. That is going to help us to know when current, divides and when it passes through two or more resistors serially. I established the fact that at all principal nodes, principal junctions, current shares. And if current shares at principal node, it simply tells us that any resistor, or resistors that are connected to that principal node, those resistors are in parallel. Take as an example, like here, you notice that this is a principal node. This total current shares at this point, right? Now at this point, you notice that R sub X resistor and then R sub Y resistor are connected to it. Simply telling us now that Rx and Ry are parallel resistors, okay? Now, how can we determine the current that flows through a given resistive element? Or how can we determine the voltage across such resistor in a given circuit? That is the concept of the current divider rule and the voltage divider rule. Quickly remember that when resistors are arranged in series, the same current flows through them. But what about the voltage? We learned that the voltage differs. They have different voltages, which simply means that a series arranged resistors, are you following, right? Such circuit acts as a voltage divider circuit. And in such case, you have to apply the voltage divider rule. What about in a situation where the resistors are arranged in parallel? Such circuit acts as a current divider circuit. It divides current. I've already said that at principal nodes. So for us to solve and obtain the current that flows through a particular resistor in such case, we need to apply the current divider rule, CDR. Please friends, come along with me. Let us look at this first diagram, figure 1. This is a parallel circuit. R sub X and R sub Y are in parallel because at this point a principal node, this total current which I've used I sub T, I total, to represent, on getting to this point, this principal node, principal junction, if you share into two, one will pass through this R sub X. I've referred to that as I sub X, current through R sub X. And then the other will move through and pass this R sub Y. I refer to that current flowing through this resistor as I sub Y. Now how can we determine the value of I sub X? How can we determine the value of I sub Y? Take note please, this V sub S means source voltage, or simply total voltage, the voltage produced by the cell. Are you following, right? Now all we need to do is to apply our CDR to determine the value of I sub X and I sub Y. This CDR simply helps us to use the resistance value to calculate current. And that's what we have here in question 1 and 2. To get I sub X, current through R sub X, okay, it's equal to, watch, R sub Y. This R sub Y is the resistor or the resistors that shares the current with the resistor whose current you're trying to determine. Don't worry, when we solve problems, okay, I will explain this concept of RY in this case of equation 1 better. Because I must state here, and if you put it down, it's really going to be good. In this equation 1, RY may either be one resistor or it can be more than one resistor. When we solve problem, I will tell you what I mean by this statement I just made. So that will now be divided by, RY divided by Rx plus Ry times I total. Then to get I sub y is simply equal to, now you take note I'm calculating I sub y now, so the numerator will be R sub x. That's either the resistor, say one resistor, or all other resistors that shares the current with the resistor whose current you want to determine. Like I stated, I'm going to explain that clearly when we solve problems. So I sub y is equal to R sub x all over R sub x plus R sub y multiplied by total current. That gives us equation 2, though I've written on the board here that I sub y could still be equal to I total minus I sub x. If you know I sub x already, you can actually use the total current to obtain I sub y. However, this formula is used when you now deal with simply two elements, two resistive elements. We're going to see all of this as we move on in this topic. Let us now quickly look at VDR. This time around, how to determine the voltage across a particular resistor in a given circuit. Here we have figure 2, series circuit. What is our VDR? You notice that Rx and Ry are connected in series now, okay, end to end. So how can we determine the voltage across this R sub x? And here again we have the formula, equation 3 here, that V sub x, that is the voltage across this resistor x, is equal to R sub x. Did you take note of something in the numerator here? Calculating the voltage across a particular resistor, the numerator will be that same particular resistor. Compare it with that of current divider, you'll notice a slight difference. Are you following, right, in terms of the numerator? So if I'm calculating V sub x, it's going to be R sub x divided by R sub x plus R sub y multiplied by the source voltage or the total voltage. Then to get V sub y is equal to R sub y, that is the resistor whose voltage you want to determine, divided by Rx plus Ry times the source voltage. That gives us equation 4 there. This is the analysis of the CDR formula and the VDR formula. In the next video, we're going to see how we can apply these formulas to solve problems, determine the current through a particular resistive element in a circuit, and determine the voltage through a particular resistive element in the given circuit.